I am going to record. I've been recording today just with people absent. They can get on and look at the questions if they want. 21. Your directions are divide and simplify, rationalize the denominator if necessary, assume that all variables are positive. First of all, when you see that statement, assume that all variables are positive, that is the way of saying don't worry about absolute value. The only place you have to worry about absolute value, you are outright told use absolute value when necessary, and that's up on 9, 10, 11. So on 21, our job is to divide and simplify. So in this section, first thing I would suggest is check and see, can I divide? Can I divide 9 and 11? Do they simplify anyway? And they don't. Okay, but I would always check those because the previous two, 19 and 20, they do. 21 and 22, not so much. So if we can't divide and simplify this, my job is to rationalize. And in order to rationalize, what we're trying to do is we're trying to make that a perfect cube on the bottom. I'll probably try and talk about a square root one here in a moment because that'll be an easier example, but a perfect cube. So right now we have the cube root of 11. How many of something does it take to make a perfect cube? To make a perfect cube, it's going to take 3 of something, correct? So right here, how many 11s do I have? I have 1 11 under this radical. So how many more 11s do I need to make this perfect cube? And we're going to need 2 more. And so what we're going to multiply by, it's the cube root, and I'm going to say 11 squared, as in 11 times 11. Now, what I do to the denominator, we're going to do to the numerator. So we're going to multiply the numerator by the cube root of 11 squared. If it was a square root, you just need 2 of something to make a perfect square. So you just multiply by itself. And I'll demonstrate that one in a moment. But if it's a cube root, you need 3. So right here I have 1 11 and then I have 2 more, right? Because it's 11 squared. So now, let's do the math. On top, cube root times cube root. What is 9 times 11 squared? So I know 11 squared is 121. 9 times 121? 1,009. Okay. So on top, this is going to be the cube root of 1,089. On bottom, it's 11 times 11 squared. Now, how many 11s are there? There's 3, right? So you're doing the cube root of 11 to the third. Do you understand what that's going to become? 11. 11, right? Okay. I mean, you could say, I don't know what 11 to the third is, and I probably don't have it written there. Yeah. You could say it's the cube root of some number, but you can turn around and take the cube. So the idea of this is the cube root of 11 times 11 times 11. That's just going to be 11, and it's no longer under that radical. Okay? And at that point, you can't do anything with the cube root of 1,089. So it's just the cube root of 1,089 over 11. Can I throw in a square root example while we're here? Because if we're talking about rationalizing, what's 19? We can. I'm going to throw in a different example, then I'll backtrack to 19. This is kind of like 21 part B, so to speak. Okay? This is, honestly, it's just 22 without all the confusing variables, is what this really is. Okay? But the idea of divide and simplify. Square root of 6 divided by square root of 5. Can I divide 6 and 5? No, 6 and 5 don't divide. So how do I rationalize? How do I get rid of the square root out of the denominator? So how do you get rid of a square root of 5? you multiply by square root of 5, yes? And so the idea here, in order to get a perfect square, you need 2 of something. So we're multiplying square root of 5 by square root of 5. What I do to the denominator, we're going to do to the numerator. So with a square root, when you're trying to rationalize, you just multiply by itself. That's the easiest thing to think there. Multiply by itself. On top, what is square root of 6 times square root of 5? Square root of 30. Good. On bottom, what is square root of 5 times square root of 5? It is 5, yes? If you want to say square root of 25, you can, but realize it just becomes 5. Okay? This was basically doing 22 without all the variables. And this is a good example to be able to do just the basics up here. Okay, because this is just a basic rationalize the denominator. Now, 19 was what you asked about, Kamara?
Yeah.
Okay, square root of 90x to the 18th divided by square root of 2x. This one is different in that I can actually divide. On 21 here, I couldn't do 9 divided by 11. My other example I threw in, I couldn't do 6 divided by 5. Can I do 90 divided by 2? Yes. So my first step recommendation is let's go ahead and simplify this. Square root of 90 divided by square root of 2 is going to be square root of 45. And while you're at it, what about square root of x to the 18th divided by square root of x? How do I do x to the 18th divided by x?
X to 17.
Yeah. If the bases are the same, so they're both x's, right? You keep the base of x and you subtract the exponent. So 18 minus 1, making this x to the 17th. So if you can divide, I highly recommend you divide there. Now, the directions were to divide, which we did, and simplify. You guys got your blue papers? You're going to have those ready to use, yes? Square root of 45. Is 45 a perfect square?
No.
No, 45 is not on my list, is it? But, think perfect squares. What on this list can divide into 45? And that's a 9, isn't it? So I'm going to rewrite this. 45 divides by 9, and it's 9 times 5. So under my radical, 9 times 5, that's still 45. X to the 17th. Can I take the square root of x to the 17th? No, because 17 does not divide by 2, right? If it's a square root, you're trying to divide by 2. So 17 does not divide by 2. Closest number below 17 that does divide by 2. And that's going to be that next number of 16. So basically, 17 doesn't divide by 2. I'm going to go for the even number below it, which is 16. So I'm going to make this 16 plus the leftover 1. And now we're actually going to take the square roots that we can take. Square root of 9. Can I do square root of 9? Square root of 9 is 3, so that's going to be out from under the radical. Square root of 5. Can I do square root of 5? No, that's not on my paper. It's not a perfect square. It's a decimal. So 5 stays under the square root. Square root of 16. Can I do square root of 16? How do I do square root of an exponent? Divide by 2, yes? And does 16 divide by 2? It does. 16 divided by 2 gives me x to the 8th. Out or in?
Out.
It's going to go out. X to the first. Does 1 divide by 2? No, so x to the first is going to stay in. Okay? So I have 3x to the 8th times the square root of 5x. Question on this, Lily? Okay. So, 3x to the 8th, square root of 5x. Not only did we practice dividing there, but we also practiced simplifying a radical, yes? All radicals should be simplified on this quiz. Most definitely. Okay, what one, Lily?
I don't know if you guys have already done it, but could we do 11?
I don't think we've really done anything together.
It's the 4th. Can we do 14 after that?
Okay. So 11 to begin with. Let's see. I think I'm going to still put 11 on this page. Now 11's got a good, we've got to talk about this, right? Because this is the one section where it says to use absolute value symbols when necessary, right? Okay. So we'll talk about yay or nay on them. The 4th root of 81, x to the 20th, y to the 8th. Okay, so directions simplify, and then we'll have to consider absolute values. So we'll talk about that in a moment. Fourth root of 81. Can I do the 4th root of 81? Grab a calculator and check, or blue paper. Can I do the 4th root of 81? Yeah, the 4th root of 81 is 3. So that 3 is going to be outside the radical now. I'm going to put over here. Can I do the 4th root of x to the 20? How do I do a 4th root of an exponent? We're going to divide, yes? Whoops. And 20 divided by 4 makes this x to the 5th. Can I do the 4th root of y to the 8th? Same thing. Divide by 4 and it becomes y to the 2nd. Now, I just did a 4th root. Do I need to consider absolute value? Can a 4th root have a negative answer? No. Okay. A 4th root, anytime it's an even root, so square root, 4th root, we need to consider absolute value. And we're considering absolute value because this 4 is even, because it's an even root. Do you remember me doing that in the notes? I'd point out that that root is an even root. And I'd say, okay, I'm going to throw absolute values on this, and we're going to decide if they need to stay or not. The idea, whatever comes out of the 4th root has to have positive. Do I need absolute value to make the number 3 positive? No? 3 is positive, isn't it? So 3 is going to stay, we don't need absolute value for 3. Okay, 3 is already positive. I don't need absolute value to tell me positive. What about x to the 5th? Do I need absolute value to make sure x to the 5th is positive? Yeah, because, okay, here's the deal, guys. What if x is negative? And if I do a negative and raise it to the 5th power, that negative is still going to be a negative. So basically, because that x to the fifth is odd, we need absolute value to ensure it is a positive value. What about y to the second? Do I need absolute value to make y to the second positive? No, because what happens? If you take a negative value and you square it, a negative times a negative is a positive. And so we do not need absolute value around y to the second. Okay. So basically, it was an even root. That's why we had to consider absolute value. Anything that ended up with an odd exponent is what had to keep the absolute value. Okay? She's throwing pencils back there.
I know.
Are you scared of now, Olivia?
A little bit. I've always been scared of her.
Okay, so does that help a little bit on that section? And I will say, that was number 11, we had to consider square root. If you look at number 10, I never put any square root, I'm saying the wrong word. I'm so not making sense. On number 10, I never put any absolute value. And why did I never use absolute value on number 10? Because it was an odd cube root. Okay, and can we have a negative cube root?
No.
You can. Yeah. Try it on your calculator. Take the cube root of -8 and you get -2. Okay, so you can have an odd cube root. If it's odd, it's okay to have negatives, which is why I never use absolute value. Okay? It's the square roots, the fourth roots that it is a problem. Okay. So I've got that my mind reading done for today. Okay, so are we better in that section then? Okay. What did you say earlier?
14.
14. Okay. You guys got what you need here? I'm going to go to a new screen. Cube root of 128 a to the 13th b to the 6th. Okay, guys. I will tell you the hardest part about this is that, honestly, we have to think cube roots. That's probably the most confusing thing about this is we're in cube root world instead of square root world. So, as I look at 128, can I take the cube root of 128? No. 128 does not divide, or is not on my cube root list. So grab your calculator and look and see, okay, does 128 divide by 125? No, I get a decimal. Okay, so then I'm going to say, does 128 divide by 64?
Yeah.
And it does, right? So that's where we're going to take, under our cube root here, 128, it divides by 64, and it's 64 times 2. And I picked 64 because it's here on my cube root list. Now, can I take the cube root of b to the 13th? No, because 13 does not divide by what? 3. So this is where we have to think a little differently again, right? 13. What's the closest number below 13 that divides by 3?
12.
So does 12 divide by 3? Yeah, and that's the next number below it. So I'm going to break my A's into A to the 12th and A to the 1st. If I need to go down another number, I could have. It's just so happened that 12 divided by 3. And we've got to consider B's. B to the 6th. Can I take the cube root of b to the 6th? Yes, because 6 divides by 3. So at b to the 6th, I'm just going to leave for right now. Okay. What is the cube root of 64? 4. So what do I do with that 4? It goes outside. Can I do the cube root of 2? Nope. So where is that going to go? Two is going to stay under my radical, under my cube root. Okay. Cube root of a to the 12th. Can I do cube root of a to the 12th? In other words, does 12 divide by 3? It does, and that becomes a to the 4th, and that's going to be out front. Can I do the cube root of a to the 1st? No. 1 does not divide by 3, so a to the 1st is just going to stay a to the 1st under the radical. Can I do the cube root of b to the 6th? Does 6 divide by 3? Certainly does, and that becomes b squared, and that's going to go outside. So you've got a 4, a to the 4th, b to the 2nd, cube root of 2a. Make sure you write that little 3 in, indicating it is a cube root. Okay. Debating where to go next. Doug?
So on number 42, if we put it x to 1/3, then we still get the credit for that.
Possibly. I don't remember how I had. I mean, I'm guessing the directions on the quiz on 42 would probably read similar, write each expression in simplest form. The rule I try to suggest is if they start in radicals, you should put your answer in radicals. However, if you get to x to the 1/3, I don't know that if I'd take off or not necessarily. If you can do all the work up to that point right, I don't know that I'd necessarily take off. Does that make sense?
Yeah.
Will you 34?
We can, whatever it is. Okay. 34 is the request. Okay. 34, they want this in radical form. That's the big deal. Okay. Right now it's in a decimal form. Well, I don't really have a way to go from a decimal exponent to radical. So this decimal I need to turn into a fraction. What do you know about 1.5? 1.5 is 1 and a half if you want to go that route. Some of you need that route, some of you don't. So if we say that's okay, a to the 1.5, we need just a fraction though. So how do I take this mixed number and make it improper?
3/2.
Because 2 times the whole number 1 is 2, plus the numerator 1 is 3, over the same denominator. So a to the 3/2. Now, here's the big thing for me. Can you take a to the 3/2 and write it as a radical? That is a big basic skill I need you to be able to do on this quiz. And I'm going to say you have a 50-50 shot of getting this part right. We can either do a cube root here and a 2 as the power, or a square root here and a 3 as the power. Got a 50-50 shot. Where's the 2 go? Where's the 3 go? What have I always said all chapter long or all section long? My denominator is my root. So that denominator of 2 means this is a square root. The power of 3 means this is, actually the numerator of 3 means this is a power of 3. Okay? I don't remember exactly what I have on the quiz, but I tried to keep it more basic in this section, so it's not necessarily that you're going to see a decimal. But if I give you a to the 3 halves, can you go to the square root of a to the third? Can you get that basic connection? Okay? Now, I will say on this particular problem, it does simplify one step. And again, I don't remember what I have on the quiz to know. It may not necessarily, it's not so much to me about the simplifying on the quiz as can you go from here to here? Why do I say this simplifies? Are there sets of 2a's here? Yeah, if it's a square root, it needs sets of 2. Are there sets of 2 in here? There is. 3 does not divide by 2. But what's right below 3 that does divide by 2? And that is a to the second. And you have a leftover a to the first. So on this particular one, we are simplifying. What's the square root of a to the second? So if I take that 2 and divide, that's going to be a to the first out front. And then what about square root of a to the first? That's going to stay. That looks really weird that I wrote all those 1s and 2s in. Not sure. My answer key I know is going to say a square root of a. I'm not going to write all the 1s and 2s that can be left invisible there. And again, that step right there is big in my mind. Can you take a to the 3 halves and rewrite it as the square root of a to the third? Okay. This particular example, yes, it has some other simplifying and whatnot. While I'm here, can you do 38? And again, I'm just trying to, a basic example here. 38 is the 4th root of b raised to the 3rd power. Directions ask for an exponential form. I feel like if you understand that direction, you have a 50-50 shot of getting this right. Because if it's exponent form, it's going to be b to some power. 50-50 shot, guys. 3 over 4, 4 over 3. My root here is my denominator, right? So 3 is the power, and that's the numerator. 4 is your denominator. That's an easy point, right? Being able to know which way to write it. Okay. Should we talk about something like 42? Should we talk about something like 28 and the rationalizing up there? Maybe even something like 24, where it's adding and subtracting those radicals.
Can we do 23?
We can. $23. Cube root of xy minus 3 cube root of xy. The directions just say simplify. The key here is, can I subtract these?
Yeah.
Yes, because what's the rule in order to subtract them? They have to have that same radical there, right? What do you notice about both of these? They are both cube root of xy. So what is 14 cube root of xy minus 3 cube root of xy? Or in other words, what's 14 of something minus 3 of something? 11 of something. And in this case, it's 11 of cube root of xy. So what I was trying to point out to you on that one is just make sure that if they're like radicals, so the same type of root, the same pieces under the radical, you can add and subtract them. Okay. Now, I don't know if you guys necessarily want to do 24, but if you look at 24, can I add and subtract 24 as is? No, because they're not like radicals. Does that mean I should just write cannot be simplified and move on? No, you need to simplify, which means you need to pull out the blue paper, right? Should I go through 24 and remind you guys how to do that one? Yes? Okay. I'm going for a new screen, though. Maybe. Okay. It kills me on the quiz when I see people say this is the square root of 60. And it kills me when I see people say it's not possible. Because I disagree with both. Okay. First of all, in order to add and subtract, they have to be the same radical. So can I add and subtract them as is? No. Thus, the whole square root of 60 thing, no go. However, I'm not going to say it cannot be done because I'm going to see what kind of simplifying I can do using my blue paper. What do you know about square root of 20? 20 is not on my blue paper, is it? But what does it divide by that is on my blue paper? 20 divides by 4. And so this is 4 times 5. We picked 4 because the square root of 4 is 2. So the square root of 4 is 2. That 2 is going to go outside. And it's 2 square root of 5. Okay. Plus square root of 45. Is square root of 45 on my paper? No. But what is on my paper that 45 divides by? 9? This is where you take your calculator and you do 45 divided by 36. No, I get a decimal. 45 divided by 25. No, I got a decimal. 45 divided by 16. No, I got a decimal. Oh, 45 divided by 9. You get 5. So 9 times 5. What is the square root of 9? 3. What is the square root of 5? Still square root of 5. What about the square root of 5? We're just going to carry it down. Okay? And it's kind of math magic. They just so happen to all have square root of 5. So that's a really good clue that we did this right. Okay, final step. What is 2 square root of 5 plus 3 square root of 5 minus square root of 5? 4 square root of 5, because there is an invisible 1 in front of that last one if you need it. So 2 plus 3 is 5 minus 1 is 4 square root of 5. Okay, guys. First of all, I didn't do a calculator check today. I kind of did a calculator check yesterday, right? You know if your calculator is not allowed on the quiz. Okay? This quiz and the test at the end of the chapter, if your calculator simplifies square roots, I will not allow you to use it tomorrow. So, if you were unsure for some reason, then you need to ask me.
Actually, I never really checked it.
I say I checked them yesterday. Oh, yours is the one I'm gonna have to use to check on, but make sure. Let's go ahead and stop this.